and then I do this, and now we continue on. Namely that the basic strategy for solving a square root radical equation is to square both sides, and then, very important, you must check your answer. Okay, so if x really does equal 7/2, I could do this. And I'll get a truthful answer. I'll get 1 equals 1, which is true. 1 does not equal any other number, so let's see. This is the square root of 4/1 times 7/2 minus 13. 2 goes into 2 one time, 2 goes into 4 two times. So 2 times 7 is 14. I will have the square root of 14 minus 13. Oh yeah, and all of these equal 1. Well, we know it will, right? Because this is the square root of 1 equals 1. So 1 equals 1. So yes, this is true. And therefore, x really does equal 7/2 for this equation. Okay, but we are going to encounter some solutions that do not check, which is why you have to check. Okay, let me solve. And then move this, solve radicals. Okay, solve radical equations. And I need to go to correct. The things we have to do because we're using technology. Okay. And it was supposed to mean less work. All right, let's move on. Now we have to notice a slight variation in the strategy. We're not just going to square both sides. We have to isolate the radical term first. So here's the problem. The square root of 5x plus 2 equals 13. So I've got to get the square root term by itself first. So I'll subtract both sides. 2 minus 2 is 0, leaving me with the square root of 5x all by itself on the left, which is what I want. What matters is that it be on one side or the other all by itself. Now I can square both sides. I couldn't square both sides until I had that radical all by itself. So now I will square both sides. So 5x, because I squared a square root, I get what's underneath, equals 11 times 11 is 121. Or you can put it in your calculator and find out. Now, this is 5x. I can solve for x just by dividing by 5 and dividing by 5. And if that is truly the solution, then I can substitute 121 over 5 and get the right answer. Okay, just making sure. All right, now I have to return to the original equation, which is the square root of 5x plus 2 equals 13. Now, I'm just going to see if this side comes out to 13. If it does, then I'll have 13 equals 13, which is the proof that that is the correct answer. So let's see. I will have the square root of 5 times 121 over 5 plus 2 equals 13. Now I need more room, so I'm going to make a bigger square root. This will be 5 over 1. I'm going to write 5 as a fraction because I'm multiplying it by a fraction. 121 over 5. All right, the 5's cancel, leaving me with just 121 over 1, which is 121. So I'll have the square root of 121 plus 2 equals 13. The square root of 121 is 11, the principal square root. So 11 plus 2 equals 13. Yes, it does. Okay, that's true. So that means this is the correct solution. And we were lucky. Believe me, we were lucky. Let's do another one. As you can see, the basic idea of these is not hard at all. You just, basically, you square both sides once you have your square root all by itself. This is number 3. You'll have one like it, but maybe not the exact same numbers. Okay, now. I've got the radical isolated, so I'm going to go ahead and square both sides. That'll give me x plus 4 over here, the whole reason I do it. Over here, I'm going to have negative 5 times negative 5. So I will have x plus 4 equals positive 25. And then I'll subtract 4 and subtract 4. 4 minus 4 is 0, so I will have x equals 21. Presumably that's the right answer. Let's see. I go back to the original equation. And I take 21 and I stick it in there. Uh-oh. That's not true. Positive 5 does not equal negative 5. They're two entirely different numbers. So this is false. Which means 21 is not the solution of the equation. But it was the only number we could come up with. So this is one of those cases where the correct answer is no solution. even though I actually did everything right. I can still get no solution. Some equations are just not solvable. Okay. So this is to introduce you to the possibility. There is no solution, but let's see, can I move this over? Okay, I was just looking to kind of come over to the right a little bit, but I can do this. 21 is called an extraneous solution. The heart of this word is the word extra. It's an extra number that got thrown in as a result of our squaring both sides. Okay, this is 21 is the solution of x plus 4 equals 25. That's true. But it's not the solution of the original equation. And that happens quite a bit here. Let's go to number 4. Where we have x minus 9 the square root of x minus 3. Double checking to make sure that's right. This is a very typical quadratic equation. No, it's not. I'm lying. It's a very typical radical equation. Now what I do is square both sides to get that x out. So I'll square the left and I will square the right. Squaring the left side gives me x minus 9 times x minus 9. And that equals, when I square a square root, I get what's underneath. Ta-da! So the only work is going to come from over here where I have to square, where I have to multiply x minus 9 times x minus 9. So the x will multiply the x and multiply the minus 9, and the minus 9 will multiply the x, and the minus 9 will multiply the x. So we will have x squared minus 9x minus 9x plus 81 equals x minus 3. Now this, again, I said this yesterday, this is where you have to be very, very careful, because when you square a binomial like this, you do not end up with conjugates. You don't drop out the middle terms. Instead, you get double the middle term. This is x squared minus 18x plus 81 equals x minus 3. Now, When you solve a quadratic equation, which is what that is, it's an equation with highest power 2. You're going to pull everything over to one side and set it equal to 0. Well, that was dumb. Was that dumb? Yeah, it was kind of dumb. Okay. No, it wasn't dumb. It was just careless. All right, I want to move the x over, so I have to subtract it from here, so I'll get 0. I also want to move the -3, so I have to add 3, so I can get -3 plus 3 is 0. So I end up, for all intents and purposes, with 0 plus 0. Well, I have to do the same thing on the other side, so I have to subtract this x from this side as well, and I have to add 3 to this side as well. And that will give me x squared minus 19x plus 84 equals 0 plus 0 is just 0. I think we'll agree on that. Okay, now, there. Now, I've got x squared minus 19x plus 84 equals 0. This is factorable. I'm going to factor it. Is it factorable? I bet it is. Okay, 84 equals 1 times 84 and 2 times 42 and 3. Oh, I'm going to get the calculator. There we go. I'm going to use my trick that I like a lot, clear that. And since I'm looking for roots of 80, I'm looking for factors of 84, what I'm going to type is 84 divided by x. Not graph, I don't care what it graphs as. There. Okay, now I need two factors that would add up to -19. And both of the factors, because 84 is positive, they will both be either positive or both be negative. So the only way I'm going to get two numbers that add up to -19 is to go up to the negative factors. So -1 times -84, -2 times -42, -3 times -28, -4 times -21, -6 times -14, that would be -20. -7 times -12 would be -19. I mean, -7 plus -12 would be -19. Yes. Okay. See how easy that was? It was easier than having to think too hard. Don't want to think too hard. Okay. So what will this do for us? This will give us, because there's a 1 in front of the x squared, we can use the easier grouping method of just going straight to parentheses. -7 minus 12. That's going to be the factorization. And I set each factor equal to 0. X minus 7 equals 0. X minus 12 equals 0. Plus 7 plus 7 x equals 7 plus 12 plus 12. Negative 12 plus 12 is 0, left with an x on the left and a 12 on the right. So that means I have two possible answers. There are now a number of possibilities. One possibility, both of these answers check. Another possibility, neither of the answers checks. A third possibility, one checks and one doesn't. So here are your possibilities. No solutions. Two solutions. Or one solution. One solution and one extraneous. We're going to have to check them both. Yeah. So I go back to the original equation. Now this is my check. X minus 9 equals the square root of x minus 3. Let's try x equals 7 first. 7 minus 9 equals the square root of 7 minus 3. 7 minus 9 is negative 2. The square root of 7 minus 3 is 4. Negative 2 equals, the square root of 4 is 2. So negative 2 equals 2. That's false. So that means 7 doesn't work. It does not automatically mean that 12 does work. 12 might not work also. Okay, this time we're going to use x equals 12. 12 minus 9 equals the square root of 12 minus 3. 12 minus 9 is 3. 12 minus 3 is 9, so we have the square root of 9. So 3 really does equal 3. The square root of 9 is 3. So now we know that x equals 12 is true. And that is our only solution. And if you put 7 and 12 in there, 7, 12 in the answer box in my math lab, your whole problem will be counted wrong rather than half of it being counted right. So be aware of that. You have to check, even though I agree with you. If you're saying you hate to check answers, I hate to check answers. But when you have to do it, you have to do it. So, that is the most common occurrence when you're solving a quadratic equation, a radical equation. Okay, now we have a word problem, a good old-fashioned word problem. So I'm going to, I guess I'm not going to. It says a formula of R equals, this is number 5. Okay, R equals 2 times the square root of 5L. This can be used to approximate the speed, r, in miles per hour of a car that has left skid marks that are in feet, that are L feet long, of a car that has left skid marks L feet long. For those of you who are thinking of going into criminal justice, you'll be using this, I think. Okay, probably it's in a computer, small little computer. How far will a car skid at 80 miles per hour? R is the speed, so what we're going to have is 80 miles per hour equals 2 times the square root of 5 times L. And we're going to find out. Okay, the first thing you do is see this number outside the radical. This is 2 times the square root of 5L. You want to divide both sides by 2 to get rid of that 2. You don't need it, it just complicates the story. So the 2's cancel over here, leaving you with the square root of 5L. Over here, you get 40. 80 divided by 2 is 40. Now you have a radical equation. You're going to square both sides. So 40 squared. And the square root of 5L squared. Well, this one's easy because squaring a square root takes the top off, leaving you with what's underneath. But this, on the other hand, probably is not hard because all you have to do is say 40 times 40, that's 0, 0, 16. Okay, so that'll be 1600. Or you can put it in your calculator. So what we have now is 1600 minus 5 equals 5L. Divide both sides by 5. Okay, 5 into 1600. I just feel like doing it by hand when I think it's going to be easy. My basically lazy nature. 16 minus 15 is 1. Bring down the 0, that'll be 10. 5 into 10 is 2. 2 times 5 is 10. 10 minus 10 is 0. Bring down the other 0. 5 into 0 is 0. So we will get 320. 320 equals L. So if the car is traveling at 80 miles per hour, it's going to leave a skid mark 320 feet long? I don't think so. Let's see what the answer is. 320 is really long. They're going to fry the driver. He just picked up the straight out of jail card. Okay, here's your other word problem. Let me go to another page. There we are. Okay, what I really want to do is go ahead and reduce all this so that I can get my secret weapon. Yes, indeed. I love this tool, Snip and Sketch. Okay, and it comes free with Windows 10. It's in accessories, I think. Maybe not. Maybe it's somewhere else now. Okay, so back up. Here we go. What I want to do is copy it. Well, I copied it. I want to paste this here so it'll be easier for everyone to read. There we go. So here's what the problem says. At a height of h meters above the ground, you can see v kilometers to the horizon. You know that. Sometimes you can't necessarily see the horizon, but if you can rise up off the ground, maybe there's a little hill between you. Here's you. And there are your eyes, and you're looking. If the ground rises, it would definitely help you to somehow get higher so that you can see the horizon, so that you can see over the mountains to the horizon that's out here somewhere. Now our friend can see almost forever. Okay, now that would take a certain amount of I don't know, buoyancy. Well, let's see what this says. Oh, gotta flatten. Okay, at a height of h meters above the ground, so our friend is h meters above the ground. Somehow he found a platform and now he's h meters above the ground. You can see v kilometers to the horizon. So v kilometers. And this is h meters. These numbers are related by a formula. V, the distance in kilometers, to the horizon equals 3.5 times the square root of h. Okay, so that's the distance in meters to the horizon. No, that's the distance, that's the height in meters above the Earth. Then you can see v kilometers to the horizon. How far can you see to the horizon? How far can you see to the horizon? That's v. What is v? How far can you see to the horizon through an airplane window? Cheating! Through an airplane window at a height or altitude of 7,000 meters. Okay, so we're going to be finding V and H is 7,000 meters. Okay, now, let us see. It says here, round to the nearest whole number as needed. Round to the nearest whole number. Let's write that down, 2. Round to nearest whole number. Okay, we'll do that. That means I have to pull out my calculator. That is code for pull out your calculator. Decimals would be allowed if they didn't just want the whole number. Okay. So I'm going to clear. I'm going to go second quit. That gives me my blank screen. Sometimes clearing is enough. Sometimes second quit works. I haven't found a rule yet. It's just if one works, if one doesn't work, I do the other. Either clear or second mode right there. I'm pointing with my finger. You can't see me. Can you see my I hope you can see the arrow. I hope you can. Anyway, what I'm doing is I'm hovering over the mode key, and above the mode key is quit. So the way you access quit is you push the second key first and then mode, and that gives you quit. Either that or clear will get you to a blank screen. So now, this is what I want to do. I want to multiply 3.5 times the square root of 7,000. So here we go. Pull that up some. 3.5 times 700. No. Clear, my favorite button. It erases all the evidence. 3.5 second x squared, 7,000. And then, if you have the old form, you have to close your parentheses. If you have the new one like me, I have to click the right arrow key, or at least it's nice to do that, to get to the outside. That signals the calculator that I'm done putting stuff under the square root sign. Okay, so I'm going to hit enter. Now I get 292.83, blah, 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 blah. They want the whole number part. The whole number part of any decimal is the part to the left of the decimal. But I have to round. To get the whole number part that starts here and goes to the left, I have to look at the first decimal point to the right and see if that 8 is going to round up the 2 to a 3 or not. But it does, because 8 is bigger than 5. If this is a number 5, 6, 7, 8, or 9, it's going to cause the 2 to round up to a 3. So the answer to this problem is going to be 293. Is that right? I don't know. That just doesn't sound right, but might be 293. 5. I hit 5. No. 3. There we go. Check my answer. How am I going to check my answer? Oh, go away. Here we are. Hey, what can I say? The horizon is 293 kilometers away. That is one heck of a long distance. Amazing what an airplane will do. Okay, let's all go buy an airplane. Or not. All right, let's go back and talk about what we've done. The basic strategy is to square both sides. But first, sometimes you have to isolate your radical. In this case, it's a square root radical. You've got to get it by itself. And that's what we had to do with this 2. Then we could square both sides. Sometimes you will get no solution. None of your answers will give you a true answer. Sometimes both answers give you a true answer. Most of the time, it's one of the answers or the other, which is why you have to check your work. Be careful when you're squaring a binomial. Remember, they're not conjugates like yesterday. And this looks hard, but it's not. All you have to do is solve a radical equation. And over here, you don't even have to do that because you're solving for V. All you have to do is stick 7,000 under there, or whatever the number is on your version of the problem, and then come up with another, round it like you're told to do, and come up with an answer. It's going to be in kilometers, but you don't have to write the kilometers. It's already written for you. Discussion about what we did. Discussion, anybody?
I'm good.
That's great. Okay, then let us move on. I'm going to unshare and move along. Wow. I always make too many pages, except when I don't, and then I have to make more right in the middle. Okay, you can go. Goodbye. Now, there we are. Let us go down to applications of the Pythagorean theorem. See, there are just 3 problems here, so we might as well get them out of the way. They're the same basic kind of problem. I really should have put them in with the others. But I did want to make it outstanding to everybody that we're talking about problems with the Pythagorean theorem in particular. Okay, which is a squared plus b squared equals c squared. Okay, so there we are, and I will bring back my paper, and I will once again share my screen, and we'll do these 3 little problems. Okay. So here I have a triangle. Looking at the triangle, a right triangle, find the length of the side not given. Okay, so what they have is a triangle. Pretend it's a right triangle, that is, pretend this is a straight side. And B and C, and they tell you what A is. A is the square root of 7, and C is 10. So C is 10. and A is the square root of 7, and you have no idea what B is. We have to find B. Okay, well, I start off with A squared plus B squared equals C squared. So A squared is going to be the square root of 7 squared. Plus B squared, nope, don't know what B is. And C is 10, which means we'll have 10 squared. Now the square root of 7 squared is 7 plus B squared equals 100. And then I subtract 7 from both sides so I can solve for B. Well, for B squared, first I have to solve for B squared. 100 minus 7 is 93. And so B squared equals 93. Well, okay, actually, what we're going to do, what we would normally do to solve this equation is this. I would take the square root of the left side to undo the square, and I would take the square root of the right side, being sure to add a plus or a minus, because every positive number in the real number system has two square roots, a principal square root, which is positive, and a negative square root. However, we're dealing with length here. Can you imagine a negative length? I cannot. So in this case, we're going to forget that negative, because we're dealing with a semi-real life situation. We know that the only answer that will make sense is positive. So forget the negative in this case. The square root of B squared is B, so the exact answer is B equals the square root of 93. But if you're maybe helping your kid build a triangle, you're not going to go to Lowe's and say, hey, I need the square root of 93 feet of wood. No, you're probably going to put it in your calculator. See, it says type an exact answer using radicals as needed. Okay, I'm going to do that, and I'm going to make it bigger so everybody can see. Okay, I'm going to go to the square root 93 and check my answer. Good job, Barb. Now give an approximate answer, and you have to read the blue words because it tells you what you have to round to. It says round to 3 decimal places as needed. Okay, that means I need a calculator. Clear. The square root of 93. Enter. Now look at this. Here's the whole number part, but they want to 3 decimal places. That means I have to look at the 4th decimal place to find out if that 3 is going to be rounded up to a 4. If this number is bigger than 5, I will round the 3 up to a 4. And the 4th decimal place is a number bigger than 5. 5 or bigger, I should say. It's 6, so that 6 will round the 3 up to a 4. So my answer is going to be 9.644. $9.644. Check answer. Okay, cool. You've got to remember how to round. You absolutely have to. For questions that were not rounded correctly on the exam, my math lab counted them wrong. Now, I went back in and gave partial credit, but even then it's partial credit and you lost points. So you just think of how you could improve your grade if you could remember how to round. Put a little bit of effort into remembering the right way to round. Okay, that's my speech. Let's go to the next question. Okay, how long is a guy wire reaching from the top of a 15-foot pole to a point on the ground 6 feet from the pole? Now here's what that says. It says type an exact, they're going to do the same thing. See, this means there's going to be one more question. So, okay, get ready. Now, here's what it says. That you've got a guy wire. And it's going to go from a pole, number 2. It's going to go from a pole, whoa, a wiggly pole, that's 15 feet high. And is going to attach to the ground 6 feet from the base. That makes the hypotenuse, the C side, right there. We're going to have to find C. How long is the wire? Is that what it's asking? The guy wire is exactly how many feet long, and then you've got to find the decimal approximation. And it doesn't say yet. Yeah, it makes you put in the first answer. That is such a rip. Okay, if I hit show the complete answer, it'll change all the numbers. So I don't want to do that at this point. Let's just be fair about it. All right, a squared, A is usually the vertical side, B is usually the horizontal side, C is always the slanted side. We're going to have A squared plus B squared equals C squared. So that will be 15 squared plus 6 squared equals, I don't know, squared. That's not a B, that's a C. Oh, that's why it was curved, silly goose. Okay, 15 squared is 225. I think someone should check me on that. And 6 squared is 36 equals C squared. I guess I'll check me just to make sure. The square of 15 squared is 225. Okay, so 5 plus 6 is 11, carry the 1, that'll be a 6, and then bring down the 2. That'll give me 261, and then I'll take the square root of both sides. The exact answer for C is the square root of 261. Let me see if they agree. $261. Check answer. No! The square root of 261, you turkey. Yes, I can yell at myself and call me a turkey. The square root of 261. Now, there. Knew it all along. Yes, I did. And I get answers on tests like that too. The correct answer is on the sheet, on the worksheet. Thank God you gave in worksheets. That was saying it too strongly. Okay, the guy wire is approximately round to the nearest thousandth. What's that? 3 decimal places. So round to the nearest thousandth. I'll take the square root of 261. The square root, clear, the square root of 261. Enter. All right, they want to the thousandths place. So this is 16, that's the whole number part. The decimal part is 155, that's 3. Now the fourth one is smaller than 5. The fourth place, the number in the fourth decimal place is smaller than 5, lower than 5, smaller than 5. So it will not round the 5 in the third decimal place up to 6. It won't. So our answer is going to be 16.155. Yay! One more. Okay, got to make that smaller. Oh, I'm making it bigger. There. Okay, plumbers use the Pythagorean theorem to calculate pipe length. Didn't know you'd have to do that if you were a plumber. Plumbers are pretty smart people. Where would we be without them? If a pipe is to be offset, as shown in this drawing, did I know what the offset is? No, I didn't. But now it makes sense. If a pipe is to be offset, as shown in the figure, the travel or length of the pipe is calculated using the lengths of the advance and the offset. We are ready to go to plumber's school. Cool. Okay. Find the travel, this side, if the offset is 16, the offset is 16.75 feet. Okay, number 3. So here's your travel. Here's the and here is the offset. And they tell you that the offset is 16.75 feet. Or is it inches? Inches. That would be really big. And the advance is 10.25 inches. Well, I didn't exactly draw it to their scale, did I? 10.25 inches. How big is the travel? Let's see. A squared plus B squared equals C squared. 16.75 squared plus 10.25 squared equals c squared. Let's make sure I got that right. Okay. Now, we're going to leave it up to the calculator. Have fun, calculator. Okay, we are going to take 16.75 squared plus 10.25 squared. Enter. That's a terminating decimal. If you're interested, that means this could be turned into a fraction. We're not ready yet, but it could be. No, it wants the answer in decimals. If you were to put the answer in a fraction, which is what my math lab usually likes, and in the blue words underneath the answer box, it's asking for round to the nearest thousandth. It's looking for decimals. It would mark it wrong. So you have to be careful to do what's being asked. Okay, now I'm going to take the square root. Why am I going to take the square root? Because this is going to be, what is this? There it is. 385.625. Then I'll take the square root of both sides. That's what C is going to equal. So is it asking for, it's not. Nowhere is it asking for an exact answer, which I think is wonderful. So we're going to take the square root of that number. So second x squared. Now, look, this is cool. What I can do is, oh, I used to remember how to do this. Second, and no, okay. I don't remember how to do it. Doggone it. All right, second x squared. 385.625. 385.625, enter. And it wants it rounded to the thousandths place, which is 3 decimal places. So I count over 1, 2, 3 decimal places. The number in the 4th decimal place is lower, smaller than 5. Therefore, it will not cause the 7 in the 3rd decimal place to get rounded up to 8. So this is our answer, 19.637. 19.637. Check answer. Yay! Okay, that's it for those problems. Now, I want to take you to see something I made for you yesterday. Now, okay, we are going to have to go to Canvas to do this. And it's going to yell at me, as you'll see, new password in 7 days. Your password will expire. Okay. Here we are in your Canvas class, and I'm going to click on modules. And right up here at the top is number charts. If you click on number charts, the first 20 perfect squares, you will see a list of numbers and their squares. So for instance, the square root of 15 that we looked up, that I didn't have to look up, I did just to make sure, is if you square 15, you get 225. If you square 16, you get 256. If you square 6, you get 36. So you've got the first 20 perfect squares there. Okay. Now, also, perfect square roots. So the square root of 4 is 2, the square root of 9 is 3, and so on and so forth. The square root of 196 is 14, the square root of 225 is 15, all the way up to the square root of 361, which is 19. And while I was at it, I looked up a table on the perfect cubes. Right there, this isn't as nice. But anyway, it tells you that the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. And so on and so forth down to 1,000. The cube root of 1,000 is 10. So you've got the first 10 perfect cube roots there. And this is just to help you with the work you're doing right now. So it'll help. Okay, I am guilt-ridden at the thought of letting you out 5 minutes early, but I have nothing more to share with you. So why don't I just hang around and answer your questions if you have any. And if you don't have any, you are free to go. And I'm going to stop recording.
Have a good day.
Thank you, you too.